Hi, I'm going to go through the names of network with you today. There's different names here, depends on what rules they're following. So I've got a diagram here on the right and see if I can call it a special name. For example, the first one I'm going to go through is a transversal trial. Sometimes we call it transversal graph. The rules for transversal trial, okay, you have to use all the line, and at the same time you cannot repeat the lines. Okay, so you have to use all the line, but you cannot repeat all the lines. So now I'm going to go through. Doesn't matter which point you start. Okay, it may not work as when you start from C. So I start from A this time and see if I can use all the line without repeating the lines. Yep, I can start from A and then end at B. Okay, and I can use all the line without repeating it. Alright, now, so we can call this transversal trial, but you don't need to go through the diagram every time if the diagram is complicated. All I need to do is just check the degree of each point and then decide whether it is transversal graph. So the degree of the first point A is 3 because there's 3 lines touching it. Okay, so I call these 3 degree points, or I can call it odd degree because 3 is odd. So A is odd, the same thing as B, 1, 2, 3 lines touching it, so it's a 3 degree and it's odd. Alright, and C, only 2 lines touching it, so it is an even graph, even points. And by looking at the proof here, okay, or the restriction, as long as I've got exactly 2 odd on the graph, so I've got A is odd, B is odd, I can straight away call this a transversal graph. Okay, so only 2 odd, then I can straight away call this a transversal graph. Or sometimes all the points are even, then I can also call it transversal. For example, this one here. Okay, all the points are even. Okay, 2 lines touching it, 2 lines touching it, 2 lines touching it. This is also a transversal. Instead of going through the lines, I can just look at the points to decide whether it's transversal. And also in the exam, in the test, people will prefer you write down one of these lines as a proof. Instead of going through the network, I need these 2 lines, either one of them, to prove whether the network is transversal graph or it is not. Alright, so transversal, okay, make sure you remember the proof. And now transversal circuit. Okay, transversal circuit, so that means we have to use all the line at the same time. We cannot pass through the line twice. And the last rules, okay, because it's circuits, I need to go back to the same point. So just now I start from A and then I end up at B, which is a transversal trial, but it is not a transversal circuit because I need to get back to the same point. So if it start and end at a different point, that means I cannot call it a transversal circuit. It is not a circuit for this case. Okay. Third one, transversal cycle. Okay, this one is a little bit more. It is also you cannot repeat the points. Okay, you need to go through all the lines. You cannot repeat the line, cannot repeat the points. At the same time, you have to go back. So a lot of rules. So let's see if I can do this. Okay, start from A. I need to go back to A. Okay, oops. Start from A, go back to A without repeating the points. Okay, so I can go back to A, but I cannot use all the lines. Okay, this line I didn't use it, so I cannot call this a transversal cycle. Alright, next one, Unarian trial is pretty much the same as transversal. Okay, cannot use the lines twice. I need to pass through all the lines. But one more thing about Unarian is I have to start with 1 and then ending up with the next odd. So start from odd, start from the odd degree and end at the other odd degree. So first of all, I need only 2 odd degree. Okay, I can only have 2 odd degree. If this is odd, I can straight away say it is not a unarian. So in this case, I've got 2 odd only. This one is even, and then see if I can start from one of the odd and then end at B, the next odd. Okay, so now let's see, I can do this without repeating the line. Yes, again. Okay, so it is working, so I can go through the lines without repeating the lines and then start from one odd to the other odd. So it is a unarian trial. Okay, everything's passing. Okay, again, you don't need to go through it. Okay, all you need to do is write down the proof and then say, oh, it must be a unarian trial in this case. Okay, next one. Unarian circuit. Unarian circuit is pretty much the same as trial, but the only difference is you have to go back to the same point. It doesn't matter if it's odd number or even number, you have to go back to the same point. So let's see how it goes. So it doesn't matter which point to start. So let's see, I start from A, go to B, and then back to C. Unfortunately, I end up at B. So I start from A and then I end up at B, which is not what I want. I need to go back to the same point. Go back to the same point. So in this case, I cannot do it. So I cannot call these unarian circuits. Okay. The proof is for unarian circuits is all must be even number. Okay, all degree must be even. So this is a odd. Straight away, I can say it cannot be a unarian circuit. Okay, this is an odd degree. Okay. All right. Next one, Hamiltonian path. Okay, Hamiltonian path. The only difference is this time I can only use all the points. I have to use all the points, but the lines doesn't matter. Okay, and also I cannot repeat the points. So let's see if I can use all the points but without repeating it. So go this way and that way. I can stop anywhere, then straight away I can call this. I'm using A point, B point, C point already, so I can call this Hamiltonian path. The next one, okay, Hamiltonian cycles, pretty much the same, but this time I need to go back to the same point using all the points, but you need to go back to the same point. So you can go back straight away, didn't repeat any points, easy. So this is a Hamiltonian cycle. Unfortunately, you have to go through the path, you have to write down, or start from A, go to B, and then C. This is a Hamiltonian cycle. Okay, instead, go back to A, sorry. Instead of just write down 2 sentences or 1 sentence to do the proof, you need to write down the exact path for your proof. Okay, so this is it, the name of the networks. Now I've got some more names on the top of my head here. Okay, so just have a look. It is very easy to understand all these. I'm not going to go through all this with you. Okay, so try to read it through yourself. Thank you very much.